Hey everybody, it's Chili here. Welcome back to Intermediate C++ Game Programming Tutorial 3. Today we're learning about C strings. We're going to start at the lowest level possible and we're going to build the concept of strings up from the ground level so that we can understand C strings inside and outside. Now you may be wondering what this C string bullshit is anyways. Did Chili just have a stroke and forget how to pronounce G string? No. You probably know that string means text storage, a sequence of text characters. But there are many ways you can store text data in memory. And the method I'm going to show you today is a very low-level approach that is the most common method in C programming. It's basically built into the language and the library. Now C++ has a safer, more convenient, and sexier string class, and we'll be learning about it a little later, but for a number of reasons I want to teach the C string first. Alright, let's get started here. I'm going to get you to create an empty project. You're going to add a source file. You're going to, put in your main function. Now, we're working with strings today. And when you're working with strings, you're going to want to have a way of outputting them to the user. So we're going to use something called ConIO just for today. And ConIO isn't a standard header. It's not part of standard library. Many compilers support it, but there are many that do not support it. So I don't recommend you use ConIO usually, but it's going to fit perfectly into this tutorial. So that's what we're going to use. So if we just run this program, we're going to notice something, and that is that it exits immediately. So we don't want that behavior. So the first thing we're going to do is we're going to add a little while loop in here. Not underscore KB hit, and we're just going to put nothing in the body of that loop. And what this is going to do is it's going to loop as long as the user doesn't press something on the keyboard. So if we do this, now it's just going to wait here, press the space key, and then it exits. Great. All right. So now we have it so that it doesn't exit immediately. Let's output some text to the console. So we're going to use underscore put ch, and this puts a character onto the screen. So let's put, and it takes an int, so let's put 69. So what do you expect to go on the screen with this? You expect 6 and 9? Well, let's see what you get. You get capital E. That's not 69. What is the correlation? Well, first of all, you shouldn't expect 69 to go on the screen. This is put ch, put a single character on the screen. So you can't have two characters going up with this function call. Now, so why do you get capital E? Well, I've said it before and I'll say it again. Everything is a fucking number, and that includes text. Text is just made up of individual characters, and every character is just a number. So you need to have some kind of encoding to determine what numbers represent what characters or what glyphs. And the encoding that is most commonly seen is the Ascii encoding. And this one specifies digits and your standard English language characters here. And, there are many other encodings. We're not going to go into those details. That's too much. But most of the other encodings for the standard characters here, they use the same numbers as ASCII. So let's look up 69 in decimal. 69 in decimal is, in fact, capital E. And there you see why we got a big capital E when we passed 69 to put CH. Now, if we do multiple put ch calls, we can output multiple characters to the console, and that will output a message. Now, what do you think, what kind of message do you think this is going to put out onto the console? Take a guess. I mean, come on, you knew it was going to be pubes, right? You knew it was going to be pubes. This ain't your first rodeo here. So, we can do that. But let me tell you, that is fucking a pain in the ass. I just did this and I had to look up every single letter on this table here and put it in. It wasn't a fun time, I'm not going to lie. Luckily, we have a little trick that we can use, and it is called, wrong one. It is called the car literal. And what this does is if you put a character between two single quotes, it basically tells the compiler, take this character and put its ASCII value, replace it with its ASCII value. So this is going to replace capital P with whatever the fuck that was. I forget right now. 80, I believe. And I can do the same for the other ones. And as you can probably imagine, this is a lot easier to write. It's also a lot easier to read in the code. The effect is exactly the same. So this is alright, but I mean, like, let's say we want to output a long message, 1,000 characters. Do we really want to jam 1,000 put pixel calls into our goddamn code? Probably not. So why don't we write a function, and the function will take an array of cars, and it will put them one by one onto the console. Now, there are two main ways we can go about this. Up until now, when we've passed an array to a function, we pass a pointer to the beginning of the array, and then we pass a size that gives us the number of elements in the array. We could do that for our print function. But we could also do it a little differently. What we could do is we could create an array with our characters in it, but at the end of the array, we put a special value, and that value indicates this is the end of the array. If we do it like that, then we don't have to pass in the size. All we do is we pass in a pointer to the beginning of the array, and that's all we need. The function will just print everything until it reaches the special end of string character. And then it says, okay, this is the end of the character array, the end of the string. I can stop now. Now the question is, what value do we choose for that? Because the choice there, whatever value we choose, we can't actually print that value out anymore, because that value will now signify the end of the character array. And the value that we will choose is the value 0, because it has no meaning. It is literally, the meaning of 0 in ASCII is null, nothing. So that is going to indicate end of our string. So how do we do this? Well, create a function, void print is going to take a const car pointer. Let's call it s. Const, because we're not modifying the array of cars, we are just reading it and then putting it out. So, for, as long as star s is not equal to 0, s plus plus. So this will keep incrementing s until the value it points to is 0, which means end of string. And for each of those, we're just going to put ch star s. So this is a simple printing function, and it should work unless I have fucked something up. So now what I'm going to do is I'm going to create an array. I'm going to call this one, I'm going to go car, string, we'll call it message. And it is an array. And we will use initialization here. Wrong freaking character. So we're going to initialize this array with our character values, and at the very end, we're going to put a 0. Note that we're not putting the 0 in single quotes because we don't want the character 0, we want the actual integer value 0, signifying, null, end of string. So we create our array here. We can make this const because we're not changing it at any point. And then we are going to call print with message. And that should scan and print every character until it reaches this one, and then it will quit. And if we do that, again, we get pubes. So great, now we have a print function, and that looks a lot better than a shit ton of put ch calls. And this, my friends, is what is known as a C string. This is the default kind of string that is built into the C language and therefore into C++. It's just an array of characters, and then you have a 0, and the 0 indicates the end of the string. Now you can have more values in the array. Like I could just, I could put other character literals in here, and I could put other numbers in here. And what will happen if I build that? They will be ignored because any function that reads this as a string is going to stop once it hits the null terminator.
Jesus, you're going to kill that guy!
Of course, I'm a terminator.
So you can have garbage after your string in here in the array. The important part is the null terminator. If you put the null terminator at the beginning, it won't print out shit, obviously. So null terminator controls what part of the array is considered the string and what part is considered unused, basically. Now, let me show you something else pretty cool. Let's go const car message 2. is equal to, and let me put up here some double quotes, and we're going to go pubes exclamation mark. So what do you think is going to happen here? Well, let's run it and find out. Run this fucker. Pubes, double pubes. All right. You might be saying, okay, so this allows us to create basically an array of cars. Difference between this and this is, well, you might be wondering, where is the null terminator, right? We don't have any null terminator. That is the magic of the double quotes. The double quotes creates basically an array of cars, but it also sticks in a null terminator at the end for you, so you don't have to put it in manually. And I mean, obviously it's shorter than this. You don't have to write all the single quotes and the commas every time. And you get the null terminator in there. There's only one problem, one little issue, is that you got to remember this array. You count the number of characters in here. There's 1, 2, 3, 4, 5, 6 characters. You say, okay, this array has a size of 6 elements. Wrong. 7 elements, because you always get the null terminator when you use double quotes. People fuck that shit up all the time. So remember, whenever you're creating a string with double quotes, you're going to get an extra element in there, an extra character for the null terminator. Don't forget.
Come with me if you want to live.
Now, what happens if we want to type a double quote in our string? If we put a double quote here, no, wrong one. If we put a double quote here, we got a problem, right? Because this is going to end the string, and this is going to be considered normal C++ code, but that's not what we want. So what we have in C++ is we have escapes, and you do that by pressing \, and then you press the character you want to escape to. So this will put a double quote into the string, but it's not going to end our string here in our C++ code. So now I can put a double quote into my string, and it will work just like this. There are other escapes. A couple of the main ones are if you put \n, it is going to put a new line into your string. So a new line character is going to look like this, pub, and then new line, and then es. So that does a carriage return for the and a new line on the console. What else? There's also tab. So if you go \t, that will insert a tab character in there, and you see we've tabbed over. There are other ones, but these are the main ones: escaping the double quotes, escaping the new line, escaping the tab. All right, let me show you something. I'm going to get rid of these consts here. And so what we're doing with this code here is we're creating a local array, and then we are copying these characters into that array. We could modify that array later on if we wanted. We could go message at 0 is equal to hashtag, and that will allow us to modify the array of characters. So now it prints out hashtag oobs. So we could do that. Here's another thing we could do. Instead of copying these characters into a local array, we can get a car pointer to a string itself. So let's get a car pointer into a string, and we'll call this one my wife. And I guess we need a name for the car pointer. So I'm going to call this one wife. Waifu. So we'll get a car pointer, and it's going to point to this string. So now we're not copying the characters into a local array. We're pointing directly to the string. And if we print waifu, that'll work. My wife. But if we try now and go waifu at 0 is equal to some bullshit here, we are going to have a problem. Access violation writing to location. So the reason why we have a problem here is whenever you put a basically a string like this or an initializer like this into your code, the values of those strings are going to be in the executable file. When the executable file is loaded, when you run your program and it's loaded into memory, those strings are going to be loaded into a part of memory that is read only. So if you do a car pointer, if you got a pointer here, and it's pointing to this string here. It's pointing to read-only memory. So then if you try to modify that, you're going to have a very bad time. So if you want to modify a string, you've first got to create an array in read-write memory, and you copy that string into your array here, and then you can modify it and use it. But if you get a pointer directly to a string, literal, and then you try to modify it, it's not gonna work out good for you. So don't do this. It's fine to have a pointer to a literal like that. To be safe, you should make it always a const char pointer, and that way you'll get the compiler will tell you don't do this shit. It's dumb. But if you need to modify it, you should be initializing into an array. All right, so we've done some console outputs with put ch. Let's do some console inputs, getting input from the keyboard. So that one is, strangely enough, get ch, and it returns an int. As you probably have noticed here, ASCII table only goes up to 127, and then there are extended characters that go up to 255. So the values of ASCII, they fit within a char. That's why I've been making my strings out of char type. We can just go char c is equal to get ch, and this is going to get a character from the keyboard, and then we can put it out. So we'll do put ch c, and if we run that, it's going to wait here. It's going to wait for us to hit a character, and whatever character I hit, q, there you go. Now it's on there, and if I press, now it's waiting for kb hit. If I press that, we're done. So we can get a character from the keyboard, and then we can put that onto the screen. Now I want to test something. I want to know what value I get when I hit the enter key. So I'm going to put a breakpoint here. I'm going to run this again, and I'm going to hit enter. And now we should have broken. Yes, we have. We're here. C is equal to 13, which is \r. And if we look up our trusty table, 13 corresponds to carriage return. That's the return key. So 13 is what we get when we hit the enter key, or the return key, whatever you want to call it. Now what I want to do is I want to create another function that reads input from the keyboard until the user presses the enter key. So we're going to call this one void read, and we're going to take a char pointer to a buffer. Not a string, a buffer. Different idea. The idea of a buffer is when we call the function read, we don't know how many keys the user is going to press before the user presses enter. So we pass it a big array with enough space to hold as many keys as we think the user is going to press. So we're going to do a for loop, and we're going to go char c is equal to underscore get ch. So we're initially going to get a character. And then while c is not equal to 13, we are going to keep getting characters. C is equal to underscore get ch. And we are going to keep incrementing the buffer pointer because we want to fill spaces in memory sequentially. So every time we put one in, we're going to increment the buffer pointer to point in the next location in memory. So now we're reading in characters, and we want, as long as we're reading, we want to go star buff is equal to the character C until C is equal to 13, which is the enter key. Then we quit out. Now here's the important part. At the very end here, the very last thing we write into the buffer has got to be the null character, because that indicates the end of a string. If we forget the null character, then when we pass this string to print, it's going to just keep going past the end of the string into garbage memory, into other variables, and it's going to look dumb. So here's how we're going to read in a character. This will probably work. So what do we want to do is, well, let's print out a message. Type some shit. And you might be saying, how can you do this, Chili? This is magic. You're not storing a pointer to your literal, or you're not copying your string into an array. You're putting the string directly in the function call. Yes, because this string evaluates to a pointer to the literal. So what this is doing is this is effectively passing it a pointer to this literal in read-only memory, and then print is going to print from that. And then we need an array. We need a buffer to hold our shit. So we're gonna go car in buff, and let's make it 69 characters long. That's plenty, right? No one's gonna type more than 69. And then we are gonna do read and pass it the in buff, and then we're going to print. Let's see, we're gonna do a new line, and then we're gonna print you types. God damn it, I hate everything about living in this country. All right, read. No, we want to write. Print. And we're going to print the in buff again, the stuff we just typed in. All right, so build that and run it. Type some shit. So let's type in some shit, and we're typing shit. It's not copying it. Oh, this is dumb. Should probably make it copy to the console. But then when I press enter, you typed as which is probably what I typed. I can't really tell. What we might want to do is we might want to also copy everything that we type onto the console. So we can go underscore put chc, and this will copy everything we type onto the console as we type it. So now if I type this as and then if I enter, you typed as great. All right, and that looks right. Everything's fine. Now, there's a problem with this. Can you see the problem? I spy with my little eye something the color exploit. Because, here, just think about it for a second. We're passing in a pointer to some memory where we've allocated an array. But the array has a fixed size. If the user just keeps on typing and they never press enter, you're going to start writing into memory that is outside of that buffer. You're going to start writing, and that could be other variables in your program. That could be all sorts of bad shit. You don't want to do that. So the correct way to write a function like this is to take in a second parameter, int max size. And what you're going to do here is you're going to do as long as C is less than 13 and buff is less than pend. So pend is going to be a pointer to the element after the last element in the array, basically. So how we get pend is we can go const car pointer to const pend is equal to buffer plus max size. Now this is fine except for one little detail. So when we're looping through here, we don't want to fill up the entire buffer. We have to leave a space for one character that is the null character. So we go as long as buff plus 1 is still less than pend, we can keep putting characters in. But as long as this becomes not true anymore, then we have got to quit out, write the null character into the last available space and exit. So let me just, because I don't trust anything, just put some brackets around that. And yeah, so this will work, and this will now only read in up to the amount of characters that we allow it to. So this is saying you can only put 69 things into this array. That's 68, up maximum 68 payload plus the null terminator.
So I'm coming day and night. I mean, it's terrific, right?
So now if I go like this and I just start jamming out, it's going to exit out. And it exited immediately because I kept typing, and, we passed through the KB hit thing there. But anyways, you get the idea. So this is the safe way to read in characters from the keyboard and put them into a buffer. You also have to pass in the size of the buffer. Let me just do another quick demonstration with a smaller size, 5 characters. So now if I run this, yes, I can type in 1, 2, 3, 4 characters. If I try to type in a 5th character, it doesn't let me, and it just goes ASDF. Alright, so the last thing we're going to do in this video is a simple little application here. It is going to print out a message, how many pubes to the user. The user should enter a number, and then is going to go through a loop and print out pubes that many times. Now we got all the things we need except for one thing. We need a way of converting a string to an integer value because, and you may not have thought about this before, but obviously, if you think about it, string representation and integer representation are very different. So let's say the user enters 128. So 128 in terms of string is 1, 2, no. The characters 1, 2, so let's just put the characters up here. 1, 2, 8, and then the null character, which is actually \0. So, in terms of bytes in memory, that is going to be, writing the bytes out in decimal, it's going to be 49, 50, 56, and then 0. Now, what we want to convert that to is very different. An int also has 4 bytes, but it is going to look like this. It's going to look like in the lowest order, it's going to have 128, and then 0, 0, 0, right? Because it's a small number, the values are only going to be in the low byte. The top 3 bytes are going to be zeros. So we got to convert this into this. How do we do? Well, the first step of being able to convert a string to an integer is you've got to be able to convert single digits into numbers. So this is actually quite simple. So the value, let's take a look at this table here, for example, the ASCII table. Where is it? There. All right. So if we look at the ASCII table, here are the digits 0 to 9, and we can see that they are lined up sequentially in terms of their value, and that is very useful property. So we know that 0, its value is going to be 48, and then the next one will be 49, 50, so forth. So if we take a character and we subtract 48 from its ASCII code, the result should be the value of the digit if it was a digit to begin with. So for example, 0 is 48. If we subtract 48 from 48, the result is 0. Good. If we subtract 48 from 50, the result is 2. Good. That's what we want. We want the value of this character. And if we subtract 48 from 56, the value is 8. There you go. So the first step is subtracting 48 basically from the ASCII code of each digit to get its value. So let's create a function here, and we're going to call it string to int. It's going to return an int. It is going to take a car pointer to string. And well, I guess we should probably give it a name as well. That could probably help. str to int. Should be constant car, right? Because we're not changing anything. So const car. And now what we're going to do is, let me think here. So we want to convert every digit, every character into its value as a digit. Now the problem is this works great as long as your characters are all digits, but if you insert a non-digit, you're going to have a problem. So what we do is, so to begin with, let's just make this function convert a single digit because that'll be easier and that'll prove our point. So what we will do is, so if star s is greater than or equal to 0, write the character 0, not the value 0. And star s is less than or equal to the character 9. So first we make sure that s is actually a digit. The first character in our string is a digit. And if it is, we are going to return star s minus the value of the character 0. And this should give us, well, the ASCII code of the character 0. And this should give us the value of our character that we pass in. Else, we'll just return -1. I believe that won't mess up our, that won't mess up our thing. So -1 indicates that it wasn't a digit to begin with. Now, if we do this, we should be able to work with single digits easily. So how many pubes? Let's go for 3 pubes. Pubes. That's good. Let's try it again. How many cubes? Let's go for 8 pubes. And indeed, we have got 8 pubes. So our conversion is working good. Now we just have to get it to work for multiple digits. Now, to understand how this works, let's take a look again at the number 128. This number in decimal can just be broken down into 8 times 1 plus 2 times 10 plus 1 times 100. And this is basically how you can convert any string into a value. You convert the individual digits, you get the value of the digit, and you multiply it by the place. So this is in the ones place, so we multiply by 1. We convert this ASCII code into its value, multiply by 10, convert the value, multiply by 100. Add them all up together, and you get the integer 128, this guy right here. So all we got to do is start from the end of the string, and we keep converting to the right. Now let's say the user enters a string like this, 128 fuck you 3. If we start from the end of the string here and we run until we hit an invalid character, we're going to get the value 3. But usually when you input something like this into a program, it's either going to give you an error or it's going to give you 128 up until the first invalid character. So what we want to do is we want to start when we figure out our starting point, we want to figure it out by scanning right until we reach either the null terminator or an invalid character, and then we will back it up by 1, start here, keep moving and multiplying and adding. And that's how we're going to live our life, people. So, first things first, in string to int, we want to scan to start point. And so I'm going to do const char, and these are shitty variable names, but we're going to call it p. And so p is equal to s, and then while, or we can just do a for loop actually. Yeah, for, empty there. And as long as we've got a valid digit, we're going to do p plus plus. And we'll do that there. But this has got to be p, not s, right? So p. So this will scan, and at the end of this, p will be pointing to the first invalid character. So then we just got to back it up by 1. All right, so now p is pointing to our start point. S is pointing to the start of the string, which is our end point. So now what we want to do is, first we want int value, set that to 0. We want another int, and this is going to be the place. We'll set that initially to 1. That's the value of the place, the ones place, the tens place, the hundreds place. And we're going to keep increasing it as we loop. So now we do, let me think here, for. So while p is greater than or equal to s, p P minus minus. That's not a minus. P minus minus. And then for every iteration, and we've already tested these characters, so we know that they're a digit. So all we got to do is go value is equal to star P minus the ASCII code of 0. This will give us the value of this digit. Times the place value. And we want to add an equal, we want to accumulate that into the value. And then after we do that, we have to increase the place value by a factor of 10, because we're going to move on to the next place. So we multiply and equal 10. We could put this in here as well, but it doesn't matter. Put it in here, it's fine. So this will keep looping and accumulating into the value. And then at the end, we just return value. So if the string is invalid, if it's an empty string, or if it starts with an invalid character, it's going to return 0. And that's fine too, that's fine. So scan to start point, and then in here, convert place values and accumulate. There you go. So this should now work for multi-length strings, right? Let's try it out. Let's try it out though. So how many pubes? How many pubes? Top of the morning to you. 12 pubes. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Exactly 12 pubes. How many pubes do you want? Because I want exactly 420 pubes. There you go. That's what 420 pubes looks like. And there you go. There's a function that will convert a string to an integer value. So now maybe you have a little more appreciation for code where you just, you give it a string and you get a nice int out of it. There's a little bit of work involved. It's not a huge thing, but it requires a little thinking. Now, the last thing I want to say here is that the stuff we're doing in this video, it's just an exercise. When someone is writing a real program, they never start by, creating a library of string operations that they can use. There already is a library of all these string operations that I've done in the video and much, much more. But you know what? We don't use those ones either because they are also dangerous. The good news is there is a C++ class that is a lot safer and a lot easier to use. It's called std_string. So you might be like, well, Chili, why even bother with C strings at all then? And I mean, there are a bunch of reasons why that's the case. C strings are used a lot in the Windows API, in Direct3D, in OpenGL, etc., etc. So you have to deal with them at least when you're interfacing with those libraries. B, std_string uses many, if not all of these concepts of C strings under the hood. And C, mainly the reason why I wanted to do this video is just to give us some practice with pointers. It's very synergistic from an education point of view. Teaching pointers enables us to talk about strings, and talking about strings allows us to practice what we learned with pointers. We're going to keep using C strings for a few more videos, but after that, I'm going to introduce std_string, and then we're going to be mostly just sticking to std_string from then on. Alright, so for homework, you're going to make a program that calculates Fibonacci number. So it's going to ask the user for a number. Let's say the user enters a 3. Then the program is going to say Fibonacci number 3 is 1. And yeah, so seems simple enough, but there is one condition, and that is you are not allowed to use any library functions except for the ones that I've shown you here. So you're only allowed to use getch, putch, and you're only allowed to use kbhit. You can use any of these functions here that we've created over the tutorials, but you're not allowed to include other shit. You're not allowed to use any other functions. Any functions you need, you're going to have to create that shit yourself. So yeah, user inputs a number n, and you have to print out the nth Fibonacci number. Thanks for watching. Hope you enjoyed the video. If you did, please click the like button. It helps a lot. And I will see you soon with some more C++.